Now we've learned that all of the link operators are defined as extension methods in the system.link namespace. The methods you'll find in there include the where operator for filtering, order by to order, there's joining, grouping, projection, and more. If you use a decompilation tool like .peek from JetBrains or Reflector from Redgate, you'll find a class in the base class library called enumerable. It's a static class, and all of the methods defined on it are extension methods for IEnumerable of t, or IEnumerable of tSource. tSource is the generic type parameter. These are the link operators, and since they are generic methods with that generic type parameter, they can work against any type. You can work against IEnumerable of string, of integer, and even custom types that you define in an application like invoices and purchase orders. But now imagine you are the person who is implementing that where extension method to filter data. You need to know how a user wants to filter the data when they invoke your method. Do they want to filter employees by their first name, by their last name, by their hire date, by their salary? One solution to this problem is to allow the caller to pass in some code that expresses how to do the filtering. Your where method then is responsible for building the filtered result. The user's code is responsible for determining which objects to filter. So stated another way, your code is responsible for how to filter. Someone else's code is responsible for what to filter. That's a nice separation of concerns that you can achieve with functional programming, and we'll return to that topic in a later module. For now, let's see how we can pass code around for these link operators to work. Back in the demo project, we're still working with IEnumerable of string, but what I'd like to do now is set up a generic filtering mechanism, something that works just like the where operator from system.link, so that I don't have to have extension methods every time I want to filter something differently. Before we had strings that start with, I'd like to change that to be just a generic filter. So let's come in and actually call this method filter. It's going to be a generic method that takes a generic type parameter called t, so that it can return IEnumerable of t, and take as an input IEnumerable of t, and that's what this extension method will extend, anything that's IEnumerable of t. So automatically now it can work against integers, date times, employees, and invoices. We do have to change the second parameter, however, because we're no longer looking just for strings that start with something. We need somebody to pass us some code or something that represents something that we can invoke, that we can use to test each item in the input. And if you're familiar with delegates from the first part of the course, then you know if I define a delegate, and let's define a delegate that returns bool, and call it filter delegate, and this will also take a generic type parameter so that we know the type of the parameter coming in, then we can use this delegate type as the second parameter here and say give me a filter delegate of t, and call it predicate, because what we'll do is we'll use this predicate to test each item, and if it passes we'll return it. So we can say if predicate and invoke that delegate, passing in s as the value to test against. And in fact, let's rename this a little bit. Let's call this item. That makes a little more sense since we're not just dealing with strings now. So for each item in the input, we'll invoke the predicate. If that predicate returns true, then we will add that item to the IEnumerable that we're returning. So we'll add that item to the output. Now, how can I invoke this filter method? There's a couple different ways to do that. I could define a named method. So I could say, give me a static method that returns bool called strings that start with L. It takes a string as an input parameter, and it returns true or false. Does this start with an L or not? And then I can pass this as the parameter here, the string that starts with L, and this will give me something that I can build, and this will give me something that I can execute, and it produces the same result we had before. It's just a little more flexible because now we have a filter method that can take delegates that point to other different things to filter things in a different way. I might want to filter by the length of the string, let's say. And there might be a lot of different ways that I want to filter, and it's not always reasonable to expect me to write a named method every time I want to invoke a different filter. So maybe the next time in the next piece of code in the next file, I want just the cities that start with the letter H. I'd have to write another named method to do that. In C# 2.0, again, something we learned earlier is that there is something known as the Anonymous Delegate. Right here in the code, I say, here's a delegate that takes a string as input, and then I use the curly braces to denote a method body, and I could say item starts with L. And this bit of code is just exactly like what we had before, except now we don't need a named method to do this. We can sort of inline express the code that we want to do to perform the filtering. And again, if I build this, run the application, it's still producing the same result. Almost every link operator requires one or more delegates to be passed in as a parameter. You need to write some code and pass it in so that the link operator can invoke that code and figure out what you're trying to do. This is true for ordering, for sorting, for projecting, for joining. They all need the caller to express how to sort or how to join or how to filter. And it's so prevalent that the designers of C# decided that it would be nice if there was a short and succinct syntax for producing delegates. And they looked at this bit of code and they said, we know that we are filtering and that this filter method will need a delegate. It's described right here inside of the method signature for the extension method. So why don't we just try to get rid of the delegate keyword? And we know that we're operating against strings because cities is an IEnumerable of strings. So we know this delegate always takes a string parameter. Let's remove that too. We know we're going to be returning a bool because that's what this delegate looks like. It takes a string and it returns a bool. Let's just get rid of that and use an expression like item.startsWith. And in fact, let's get rid of the curly braces because they're really not needed. But just to keep the C# compiler happy, we'll introduce a new operator known as the goes to operator, and that is the Lambda Expression operator. And what we have now is a bit of code that is still producing the exact same delegate we saw before. It's just a lot less verbose. It's a Lambda expression. The left-hand side represents the signature of the method. It takes one parameter called item. We know it's a string. We're using type inference here because we're working against IEnumerable of string. And the body of that delegate is to execute and return item.startsWithL. If we build this and run the application, it's still performing the same way. But what we've done is we've gone from that longhand delegate syntax to a much shorter Lambda expression syntax. Lambdas are the way to write delegates in C# 3 and above.